Human metabolism and its myriad chemical reactions is responsible for processing food and providing the body with energy and eliminating waste. Like all nature's organisms, cities too have a definable metabolism. Let's see how this metaphor, used in urban planning and design, changed over the last centuries. In the second half of the 19th century, Marx and Liebig described the metabolic relationship between human activities and nature and how human actions aim to regulate and control the metabolism between settlements and their surroundings. Nevertheless, in the decades after that, simple figurative translations from medicine to urban planning dominated the discussion. Calling the center of a city the buzzing heart or large road arteries are reminders of this simple approach until today. It took until 1965 and the beginning of the environmental movement when Abel Woolman published The Metabolism of Cities and applied ecological thinking to his study of a hypothetical American city of 1 million. He quantified the relations between the inflow of energy, material and water and its relation to air and water pollution and waste generation. He described the linear metabolism of industrialized cities of his time. The rising awareness of the environmental burdens of cities and the sustainability movement gave rise to the concept of circular urban metabolism. The underlying idea is that closing material and energy loops within cities reduces urbanization's negative environmental impacts and contributes to a more balanced relationship with the surrounding ecosystems. Central to the idea were integral approaches to harvesting synergies using input and outputs from different functions and activities to create local energy and material cycles. This means that spatial relations and infrastructures of exchange became crucial. In the early 21st century, the ongoing dynamics of globalization and planetary urbanization emphasized the discussion about at which scale closing cycles is best. It became apparent that the footprint of cities is not enough to sustain their needs. Similar to the broader discussion on the circular economy, approaches beyond closing loops, focusing on slowing down and keeping materials longer in the loop, and narrowing loops using fewer materials to sustain our needs became more apparent. With regenerative urban development, cities are imagined as producers of resources and ecosystem services, and not only consumers. Contemporary urban metabolism research tends to separate into two schools. One, a biophysical science engagement, ranging across the engineering and sustainability sciences, which focuses on the quantification of the amounts of materials and energy that flow through a city and its environments. And the second, focusing on social science engagement, drawing from geography, sociology, and political economy, which looks at the ways flows of energy and matter shape the urbanization process. As designers, we here in Delft try to bridge these two schools of thinking. We understand the process of designing the built environment and the spatial qualities it should provide as a means for facilitating a circular and sustainable use of resources and a way to encourage sustainable behavior, as well as a part of the bigger question on how we want to live together in future cities.